Well, good afternoon, everyone, and welcome to this National Industrial Transportation League webinar. I'm Jennifer Hedrick. I'm the Executive Director of the National Industrial Transportation League, and we're really happy that you've joined us this afternoon. As many of you know, NIT League has a multimodal focus on highway, rail, and ocean freight transportation, and we represent the shipper perspective on primarily federal legislative and regulatory issues in Washington, D.C. And additionally, we provide information sharing and education opportunities for our members and have been pleased to open up our ongoing webinar series to both members and friends of NIT League. So again, thank you all for joining this afternoon. And we're excited to continue our webinar series and kick off 2021 with this timely session on positive train control. This webinar will look at the impacts and benefits positive train control will have as currently implemented and what the future could bring. We'll hear a status update on PTC across the United States, including the Kansas City Southern Rail networks. And this webinar will ask and answer several key questions, including what does it mean for PTC to go live this month? As a US-based regulation, how does PTC impact Canada and Mexico? And where is the rail industry headed and how will PTC be leveraged? Our special guest speaker today is Doug Vogel from Kansas City Southern. Doug is the Vice President and Chief Technology Officer for KCS. He has spent 25 years in information technology, working in various industries, including transportation and logistics. He spent time at FedEx in their technology services division, serving as a senior strategic systems analyst. He joined KCS in 2010 to run corporate audit and enterprise risk management, and then transitioned to run and lead the positive train control and automate train control programs for the company. So today, Doug will walk us through his presentation and take questions at the end. And you'll all remain muted throughout the course of the session, and we welcome and encourage questions at any time. You can use the chat function or you can use the Q&A function that you see on your screens. And we are recording this session, and KCS is very kindly allowing us to circulate this recording to attendees following today's session. So again, thank you all for joining us. Doug, welcome to you, and thank you for joining us. And I'll turn it over to you to give your presentation. Thank you.
Very good. Good afternoon, everybody. Glad to be here, and a little different perspective that I'm normally speaking to other railroaders who understand this. So happy to kind of pull back the covers and give you some insight into what does PTC really mean from a shipper's perspective? Because there are some things that you need to understand that the railroads are going to have to go through to continue to meet this federal mandate. So I'll jump in here. I wanted to do a quick PTC 101, just get everybody on the same page, and talk about what PTC was really set out to do. The primary, there's really four areas, was to prevent train-to-train collisions, prevent overspeed derailments. So if a train's going too fast into a certain speed zone, whether that's permanent or a temporary speed zone, incursions into established work zones. So this is where we would have men on the ground performing work on the track, and then movement through a mainline switch in an improper position. This is where we might put a train into a siding or onto to another track. What PTC will not do, it will not prevent derailments that are caused by defects in the track or failures with some of our equipment. It also won't stop us, impacting vehicles that happen to go around the grade crossings. Will not do that, and it won't prevent, trespassers on the track. So how does PTC work? It really is a locomotive-centric system. We've put hardware and software on the locomotive, including communication technology, both radio, 220 megahertz radios, and cellular as a backup. Additionally, along the wayside, we've equipped all the signals with hardware and software and switch point monitors. On our network alone, we've installed close to 900 towers and about 10,000 different devices out there that help monitor PTC. Our locomotive fleet is running about 700. Some of the other big carriers will be in the thousands, couple thousand locomotives that are equipped with PTC. The other component is there is a back office component that helps manage information. So as trains get on our tracks, we provide them a track database, which has a GPS breadcrumb map of exactly what the terrain looks like, where all the signals are, where all the switches are. And this is what the locomotive uses as it moves down the track to make certain decisions on whether it should stop or should continue going. The piece that's not on the slide here is just above the back office would be our dispatch system. It's directly connected. So the dispatch system is how we give movement authorities to the crews to be able to occupy the track or set signals to allow them to proceed. This is what the screen looks like that the engineer and actually the conductor has the screen as well that gets to see that. The engineer is the only one who can interact with the screen. But how the system works is the software does a braking calculation, and it does this based on the consist of the train. How many cars do I have? Are they loaded or empty? The speed of the train, the terrain, am I going uphill, downhill? And then the location of the next target. And what we've got here is a good way to explain this is, we'll assume this is a red signal. We would call that a 0 mile per hour target. The train knows that, and it can see this from 5 miles out, it knows that to be able to stop this train, it's constantly going through an algorithm to say, based on how many cars, how fast we're going, this is how long it's going to take me to get there. And I want to make it clear, the engineer has full control over this train in PTC. PTC is nothing but a safety overlay. So it's not doing anything for the engineer other than giving them a heads up until if the train calculates that there is a 0 mile per hour target, and what you can assume is behind that signal, we've got maybe a train sitting just around the corner that's occupying the track, which is why they have to stop. If the engineer isn't doing what they're supposed to do and the system kicks in, it will actually flash a warning. And that's what's on the left is the warning screen. It's about 70 seconds. It's audible. It blinks. They have to acknowledge that. And what it's telling the engineer is you need to slow your speed down because based on our calculation, we're not going to get stopped in time. If ultimately, and you can see the yellow curve and the red curve, if they run out of time and they don't get that train down fast enough to a speed that will be able to stop, the system completely takes over. They now have no control over the train, and it will bring that train to a stop before that 0 mile per hour target. And this is the same way with a speed target. If the train is operating at a speed above what that maximum speed is, the engineer will get a warning. And if they don't adjust the train speed, the train will actually stop. It does not slow the train down. It brings it to a stop. And that's important because that allows us to go as a company to talk to the engineer to understand what went wrong. Was this an issue with the system? Was this an issue that they, maybe didn't understand what that restriction was? And we record and log those, and I'll show you some of our dashboards that we use to learn from our PTC experiences. As some of you may know, PTC started back in 2008 with a federal mandate. The full implementation was supposed to be done in 2018 or 2015. It was extended to 2018. Most of the railroads completed all their installation of track and wayside equipment and locomotives by 2018. And then there was a date here in December 31st, 2020, where we all needed to be fully interoperable. Fortunate to say that all the railroads made that. And what that allows is we had all built a system based on standards, kind of standalone independently. And when we brought them together, because we share equipment, we share crews, other crews operate on our tracks. All of our back office systems needed to be able to communicate and talk. All of our locomotives needed to be able to operate on another railroad's tracks. There's 40 railroads that were kind of, had this 2020 date. Like I said, everybody made it. We have over 57,000 miles of PTC equipped track, and there's 209 host-tenant relationships. And the host is the railroad who owns the track and dispatches the track. A tenant would be another railroad that would come on to that. Now, again, I can have a BNSF tenant who operates across my railroad with a CSX locomotive in the lead. And all of that through our interoperability testing will work seamlessly across the network. I show this slide just to give you a perspective of the 57,000 PTC miles. Right in the middle there's a pretty big purple bar. Well over 90% of the miles are actually freight miles. And you can see the smaller percentage of Amtrak and other commuter roads. So we as the 7 Class 1s had the heaviest lifting to equip all of our track and equipment to get there. I've got a slide here on our dashboard, our PTC status. And again, this as we talk through some of the impacts of what we can and can't do if PTC isn't functional, will help set the stage. We have an entire group, 12 people who operate 24/7 and 365 days, who do nothing but interact with our crews if there's a PTC incident. So for some reason they can't get the system initialized, the crew will contact the PTC Operations Center desk. The incident individual will work through the problem and hopefully get them back on their way. On the top part of this graph, it's a little bit of an eye chart, but I'll help you understand. There is we track how much train delay did each incident have. We've set a target for ourselves of minimum of 20 minutes. We're averaging over the last 30 days just about a 6-minute delay. So that's important that we continue to not impact the overall operation, that trains get out on time, and if we do have an incident, that we're able to resolve those and get those corrected. We've operated over 11,000 million miles of PTC tracks since we installed and turned on PTC. We track all of our problems and incidents, and the graph here with the bar chart indicates kind of which problems and incidents are affecting most trains. We also have a problem management group who does nothing but tracks those down and finds root cause. Of course, we go after the ones that have the biggest impact so that we can eliminate those and continue to reduce that train delay. Most of the other Class 1 railroads have this, and even some of the short lines have similar systems that monitor the overall operational status of PTC. Now, here's why that becomes important. What does this mean to a shipper? So this is something we pay attention to. This is from the FRA in one of their symposiums. I'll take your attention to the 3 boxes in blue here. The first one on the left, here's what this means after December 31st, 2020, so calendar year 21. any train that operates on a PTC mandated piece of track can continue operating if the system fails to initialize or if the system fails en route. But the presumption is, so what this allows us to do is, even if there is a failure with PTC, we can still operate that train. But what it specifically calls out is, if you don't have a PTC equipped locomotive in the lead of that train and you're on PTC track, you can't depart that terminal. And that's a big deal. We all haven't equipped every one of our locomotives with PTC because it's cost prohibitive and it sometimes doesn't make sense. We've tried to evaluate what the optimal number is, but there's leased locomotives. There's other circumstances that may require a locomotive to be in the lead that isn't PTC equipped. But as of January 1st, those 40 railroads operating, you can't move that train. You will have to replace that locomotive with a PTC equipped locomotive, and that can range from a 20-minute to a 2-hour delay depending on where a PTC equipped locomotive is. So we're paying very, very close attention to this one and watching any of those. As you get into calendar year 22, the regulation starts to really kind of kick in and take effect. In calendar year 22, a train can operate on PTC mainline track if you fail to initialize or if you have a malfunction. But I'll point out, operational restrictions, you don't have to worry about the CFR, I'll tell you what those are, do apply. So where before I just had to have a PTC equipped locomotive, I could continue operating the train at regular track speed. But now in calendar year 22, if this happens, on a signal track, we can only operate that train at 49 miles an hour. So I may be able to do 50, 60, or 70. But under these conditions, if I have a failure to initialize or if I have a failure en route with the system, I have to drop that speed down to 49. If it's non-signal territory, I have to drop that speed to 40. If I'm carrying PIH or TIH, those numbers go down by 10. So it'd be 40 miles an hour on signal territory and 30 miles an hour on non-signal territory. So this start to be an operational impact if I have to slow my trains down because the system has failed. And I go back to my dashboards so we understand what are the problems, how are we driving to root cause so that we don't have online failures, so that once we get to 2022, we've minimized that operational impact and potentially slowing the railroad down. 23, the only difference here is if you can't initialize, you can't depart that train. So an initialization is a crew pin. It's got to make sure you're the right crew, the right locomotive, etc. So if you can't initialize in 2023, you've got to find a locomotive that can. So again, you're into having to move power to the front of the train, and that can take 20 to a couple hours to be able to do that. The same operating restrictions are still in place in 23 with those slower speeds. So if you do have a failure en route as you're traveling, you've got to slow that train down according to if you're in signal territory, non-signal, or if you are carrying hazardous material. So really looking ahead, one of the things, the industry spent roughly $26 million implementing, what we believed, an important safety system, but probably not the system we would have implemented if allowed to, be able to build our own. But the FRA had and the government put a very prescriptive process in place for us to do that. So we all did. We then started looking as we got into this investment to say, how can we capitalize on this? How do we add value? What can we do to increase performance of the railroad, have a more reliable, more predictable railroad, more efficient railroad. Sorry, my dog, someone just came in, I apologize. One of the things that, that I showed with all of the technology that we have placed in the locomotive and at the wayside with the communications, this gives us better data management. I have the ability to monitor all of our systems. I have the ability to perform analytics and be able to operate the railroad more efficiently. The operational efficiencies, as we connect more of these systems together and leverage PTC, I get better fuel economy. I have the ability to potentially add additional capacity, leveraging the technology that's in place, and then asset reliability. With all of the technology on the system, most of the railroads, we operate to failure. We operate until the locomotive, breaks on the main line. We do inspections, but things happen. Well, with this technology and having the capability to have the system report back to me, I've now got eyes and ears on that locomotive, and I can prevent some of those things happening. Maybe take that locomotive off at the next terminal, besides continuing to operate it to failure. Because failure on a main line, depending on where you're at, can be a 4-hour outage until you can get that train back up and running, which then also has a downstream effect on all the trains behind it. So the push was, what can we do with this technology and how can we build it out to add value? And what does that mean? Again, PTC allows for a safer railroad, which clearly ends up being cost savings that drives operational costs out of us. With the data, we have the ability to be more reliable and more predictable, which as a shipper, that's one of the things that the rail industry recognizes and struggles with. Clearly, the trucking industry with what they can control has more ability to hit those times for transit. But with this technology, we can do that. With being more efficient in getting fuel savings and cost optimizations, we recognize that the trucking industry is moving towards autonomy as well, which is going to drive costs out of their operating environment too. The rail industry has come together, and we've got task force that are building standards and taxonomies, which I'll show you here, on how we continue to compete. So the AAR, which really is our industry advocate from the rail, has a group called TTCI, which is a research arm of the AAR. They've stood up a number of working groups, one that I'm a part of, which is the Automated Train Operation Group. And one of the things that we chartered was building out a taxonomy, much like the autonomous vehicles have. I believe they have a 6th level of automation in the automotive world. We built something very similar. And I'll take you through this. Where we're at today is PTC gets us about to initial automation, which means we can control acceleration, we can control deceleration, and those things are automated. That's actually done through our energy management programs, which one is from Wabtec called Trip Optimizer, and the other is from New York Air Brake called Leader. PTC gives us the safety capability to be able to prevent accidents inside of there. The next step is into enhanced automation, which we get into electronic delivery of mandatory directives. And what this does is I now have the ability from my dispatch system all the way down to the computer system on the train. I've got every movement authority, every directive is 100% of the time making it to that software, and it's being validated. If it doesn't make it to the software, it's resent. We check to ensure that the messages aren't corrupt. And at that point, now this train inside of the PTC system has the ability to fully understand how to operate that train. The next step is high automation, which is actually a pretty big step in moving into automation. This requires sensors to be put on the locomotive. You've got to be able to, with cameras, radar, LiDAR, be able to see around the corner, essentially really perform the function of a human with sensors. This is coming. Technology is going to get there. It's still very expensive, and I've got a timeline later on that will show you kind of the progression and things that that need to happen across there. Let's talk about the energy management piece, and just giving you a peek into some of this technology that we're leveraging. May not have been a direct correlation to PTC, but what we are doing is looking at the locomotive as a whole, and how do we create, again, additional automation to have a more reliable, more predictable system. So energy management, and I spoke to Wabtec, asked them if I could use this from them. I've got two of their slides in here. Leader operates similarly. Today's trip optimizer doesn't engage, and if you want to think about trip optimizer like a smart cruise control, it's actually optimizing for fuel. How do I run this train the most efficient based on the consist, based on the terrain, which may mean don't operate at top speed, may mean to operate at some speed below that. But it only engages at above 12 miles an hour, and it assumes that all the signals are green, which means if the signal is red or the engineers hit an approach signal, they're going to have to get out of trip optimizer. They may not operate that train optimally for fuel efficiency. So ideally, the longer we can have it, the system doing the energy management, the better the fuel efficiency. We've integrated it with PTC. So now it doesn't just assume all the signals are green, because PTC can now tell it, hey, there's, in 4 or 5 miles, there's a red signal, and the energy management system will then bring that train down to a speed that is most ideal. Again, though, still only operating above 12 miles an hour. The future of this is 0 to 0. If I have the ability to be able to lift that train from 0 miles per hour and then bring it back down to 0 miles per hour, which means I'm controlling the throttle and brake, which is fully capable of doing, with PTC and with Trip Optimizer, I have GPS breadcrumbs. Essentially, I could leave my terminal and take it to another terminal with an engineer pushing a button, arming the system, making sure PTC is enabled, and that train will move. Both Wabtec and New York Air Brake have tested this. They've proven this works. And in fact, KCS is working with Wabtec on a pilot program so they can continue to gather data. As you can imagine, the algorithm to understand how to get a train from 0 miles per hour if you're, on a hill with a loaded coal train, that algorithm and that, that acceleration is a lot different if you've got a bunch of empties and you're headed downhill. So they're collecting data so that the algorithm can understand that, and that they can launch that train without breaking it in two because of acceleration or deceleration. Another interesting product that's coming out that, again, through automation is giving us this ability. And again, this combines not only energy management, but PTC, which is a remote control locomotive. This technology already exists in our yard. We use these all the time for switching operations, Where it doesn't exist is out on the main line. So again, Wabtec is developing a system, and so are others, that you can have a man on the ground with a pack, and there's some pictures of what those do look like and may look like in the future, so they can operate that train with nobody in the cab and safely disconnect cars that may need to go to industry. Another great use case that KCS has all the time is, if my yard is congested, I may have to hold out 3 or 4 trains in yards or sidings that may be 5 to 6 miles away from the yard. Well, I let those crew go who left those trains. And for me today to pull those back in, I've got to call an entire new crew in to essentially do a couple hours of work. That can be a couple $1,000s. With this technology, I could possibly bring a yard personnel out to bring those in. And even, with the right technology, I could have, my train master sitting in the yard, lift that train and pull that train all the way into the yard, 5 or 6 miles away. The technology exists. We're using, again, energy management and PTC from a safety aspect, just operationally making our operations more efficient. One other component I want to talk to you about, some of you may have heard, is quasi-moving block or full moving block. And again, this is leveraging the technology that exists with PTC with some additions. I'll simply break it down. The way trains operate today is, if you see train 2 and train 1, and where we have our control point on the left-hand side and the right-hand side. Today, the way trains operate, there would be 2 signals there. Only one train would be able to occupy, and we call it blocks, occupy in between those 2 control points. With leveraging PTC and adding quasi-moving block, I can give movement authorities to the train, and because I've got technology out there, as we'll call it a switch point indicator or WIUs, I have the ability to know when that train passed that location. I can release my authority behind me, and therefore I can put 2 trains in that one block, so I can run trains closer together. Full moving block, really the only difference is rather than relying on something in the field to know, did the train go past this, so I know it's actually beyond that, I'm using location reports, which requires a higher level of precision of GPS, also relies positive train location on the end of the train. I have to know exactly where the back of that train, but similar concept. If I know where the train is at via GPS, I know how long the train is, I've got a server who's determining with a buffer margin how close I can run these trains. So I would be able to fleet trains through an area. I could bring 3 trains through here, where in the past I would only be able to use 1. So really using this technology and enhancing what we're doing is going to create a more efficient railroad. With increased capacity, that means volumes can increase. We can offer more lanes to shippers. We can put more trains out on the track. So it's a win-win. The industry has put together a notional timeline. I call it notional. There's definitely some things that have to happen for quasi-moving block and full moving block. That's a full new method of operation. The FRA has to approve those. There's regulatory things that are going on, and all of that's happening in the background. But this gives you an idea, and if your eyes are good, you can see where kind of quasi-moving block comes in. There's PTL, positive train location deployment. There's mile markers that we have to hit, knowing that to get technology to work, get over some of the regulatory hurdles and working through that. But from a technology standpoint and standards that we're developing and building and what we believe the vendors can provide, we do believe that there is some automated train operation, whether it's full autonomous, who knows, but definitely, a high automation level train that could be running, as soon as 2030. So with that, Jennifer, I will stop and see what questions we might have.
Okay, fantastic. Thank you so much, Doug. And as a reminder, we are taking questions for this final bit of our session. So please feel free to submit those via chat or the Q&A function within Zoom here. I will open up a couple questions that we have gotten in. So first question is, what % of your power units are equipped with PTC, and what are future plans?
Sure. So we have equipped all of our locomotive fleet, both KCSM and KCSR, that operate in the US. So my entire road fleet that can come to the US and operate in the US is equipped. I do have some locomotives that operate down in Mexico for emissions reasons, can't come to the US. So we did not equip those. So because of how our network operates, we decided to include our entire road fleet. I know some of the other railroads, may not have equipped all of them, but most have, because, like I said, if you've got to make a decision on can I get this train out of the terminal, you don't want to have to be replacing power with a non-equipped locomotive versus an equipped locomotive. And as the future goes, as we get into more of this automation and want to take advantage of the energy management and some of these other things, it really is going to push to, more of our fleet. The question becomes that we continue to kind of debate is, do we take our yard and local fleet and do that? It may make sense for some of our locals that do operate on the main line just for a little bit to go service customers. Our yard fleet, probably not.
Okay, great. Thanks, Doug. Another question that's come in, it sounds like the narrative has changed from railroads being concerned about this mandate to becoming positive about the impact of the changes and advantages it is bringing to the industry as a whole. Is that your assessment?
That is fair. I would say, that's a good observation. We definitely were not happy about, being told what needs to be done. Like I said, I think if the railroads were allowed to innovate, I think we would have gotten to a safety system, but I think it would have looked a little differently. But the law was the law. We all had to abide by that. And yeah, I would say towards the end of 2018, you saw that messaging change, and that's where we really got into as a group saying we've got to make something good out of this. And that's where we started exploring, how do we take it to the next level, leverage what we have. And as an industry group, we all agreed that interoperability was key. You can't go off and do this on your own. And the reason being is we share all this equipment. It's got to work as a nationwide network. I don't care if you're CSX, KCS, CP, UP, whomever, it's got to work across the entire network. So as we sat out on this, that was our goal. And that was, really our marching order was PTC will be the base. We build everything off of PTC. And as we write additional standards, they have to be interoperable. We hope to get, additional vendors in who might, we might have folks playing in the autonomous vehicle world for, again, LiDAR, radar, things that they've already developed that we may adopt to the train. But we'll put requirements, we'll put standards. You can pick the vendor as long as it operates there. So yeah, we really did, kind of turn a corner and view this as a positive. Like I said, the railroads agreed a safety system was important. I think if you look at some of BNSFs and some of the other larger roads, they were doing this well before the 2008 mandate. I will stop. I realized I had skipped over the Mexico and Canada thing. Maybe this is a good time to speak about that.
Sure.
Um, uh, we operate in Mexico. There right now there is no indication that they are going to adopt a PTC-like regulation, but just like the U.S., I'm sure, and same with Canada, is it only takes one significant accident to really change that. So I know from our perspective, we've begun the process of working with the SAT, which is the FRA equivalent, if you will, in the U.S., and beginning to have discussions with the Mexican government on how do we look to build something together and really go for a more performance-based regulation, which is what the airlines really have. It's not prescriptive. It sets safety standards that you need to build to and meet. And if you drop below that, or if an accident happens that requires them to increase the safety standards, again, it allows everybody to innovate across that. So it takes some of the regulatory burden off of the government, which quite honestly was one of the challenges that the US government and the railroads were having. Some of the paperwork that just had to be, gotten through and approvals from the FRA, it was difficult. It was, all of us were working really hard. So I know the Canadian roads are working with Transport Canada to think about a different way to, maybe achieve the same safety benefits, but come about it more as a performance regulation that allows for innovation and moves through there. Now, the interesting thing will be is, if we end up with 3 systems, how do they all work together? Do we need to run 3 systems on all the locomotives? So some of those things are still being worked out, but
Okay, great. Thanks for touching on that, Doug. A lot of questions coming in. Thank you, folks. Feel free to continue to post those. Next question, does the PTC system allow end-to-end service monitoring for interline movements that is visible to all railroads within a specific OD pair?
Not as designed. Now, that's a great question. And this is where we start leveraging the technology to say, look, why can't we do that? If I've got a GPS location, and one of the technologies I didn't talk about, which some of the railroads have, is called Whitetronics, which does some health monitoring, reports back to me every 5 minutes on where it's at, how it's performing, et cetera. But, to be able to then take that and mirror that with my consist, which then I know which customers are on my train. We're working backwards to leverage the technology to say, look, this is something that is capable for us to be able to provide not only real-time location, but even ETA. We've heard the shippers, we've heard our customers, and so we're taking the technology that's there. PTC will be a part of it. It may be my backhaul channel to get me the messages that help me kind of be able to tell that story. So something we are actively working on, because we know that's important. The Amazon effect, and me being a FedExer, I understand that. It's, we should be able to tell you where your package is at, where your rail car is at any time, and when is it going to get there. We just need to pull that information off of the systems that are operating today.
Great. I'm going to follow up with a question that is sort of along within the same vein here. Moving beyond the original goal of PTC, does PTC and a digitized network give railroads a better tool to communicate in real time key milestones, such as first mile, last mile?
It definitely does. I would say, we're still trying to unravel that right now, but clearly a challenge that we've put on ourselves to really kind of mine that data and be able to get that out of there accurately. One of the biggest problems that we have is, many times railroads, we operate in areas that don't have great cell communication. If I'm operating around the city, I've got excellent communication, but if I'm in the middle of Arkansas in the mountains, we lose that connectivity. So some of the things that we're working through, but yes, I would say that's a target. And again, we've heard that loud and clear from our customers, and something we're actively working to be able to provide. And I believe the technology is there to be able to do that. We just need to execute.
Great, good, thanks, Doug. A couple of personnel related questions, which you may or may not be able to tackle, but I'll throw them out there. One is about unions. Have unions been supportive of this approach generally?
Yeah, no, I think the safety aspect, maybe I won't speak for the union in total. What I can speak to is there was clearly some concern with engineers and conductors, as somebody watching. But I can tell you now that they've used the system, when they don't have a locomotive that has a system, we hear about it, because it gives them visibility. They can now see 5 miles ahead of them where you couldn't see that before. One of our concerns is, do they rely too much on the system? Do they start leaning on it? And again, I point out, and we continue to remind all of our engineers, is you are in full control of that train. If PTC kicks in, that means there was a problem. So don't run the train up to where it's starting to, warn you, but don't. But, I would say that, most have been very positive because it gives them visibility that they hadn't, before.
Great, good, thank you. And then a second question, personnel related. What does PTC implementation do today and in the future to crew size?
Yeah, I don't think it does anything for PTC. That's something that I think is, has to be negotiated. We're going to, advance the automation of trains regardless of crew size. That, I'll let the folks, negotiate that, because there's so much more benefit on, like I talked about, a more reliable, more consistent railroad. We would take that all day. If I have visibility into, things that are going to break before they break, that's excellent. If I can prevent accidents, and derailments, that's a very good thing. If I can save, fuel is one of our biggest costs. If we can save fuel and become operationally more efficient, that's a good thing for the business. That's a good thing for our customers, irrespective of how many people are in the cab or not in the cab.
Okay, great. Thanks, folks, for your questions. Here's another one. You mentioned the locomotive engineer cannot override the PTC system once it takes control. Does the dispatcher have capability of taking control of the train via the PTC system?
They don't. They don't have control to do that. We have the ability, if the train has to be stopped, we have the ability to cut out PTC, which would be turn it off. So if we're having a problem, and for some reason the engineer can't do that, we can cut out the system. But no, you can't initiate a braking application from the dispatch or the back office. The system is to be designed to fail safe, so that even if there is a miscommunication between those, it will stop the train to say, I'm confused and we need to get that addressed. So.
Okay, good. Thanks, Doug. Next question about capacity. When do you think rail customers might start seeing increased capacity from PTC?
Sure. I think it's still a few years out. Those changes, if we talk quasi moving block, like I said, that's a new method of operation. We've got to get FRA approval. So there's some things that have to happen, to get there. Um, I think it'll probably be a slow ramp up. As like I said, again, if you're more efficient, you're more reliable, the capacity is going to come. But where you get into running trains closer together, I think that's quite a ways out. That's definitely a few years out before you experience that full force. And even then, it's probably going to be, in spots where it makes sense to deploy that, because what you have to realize is if you're fleeting trains, you got to have a rail yard that can accept. So if I send 3 trains together, I've got to have the space in that rail yard to be able to break those apart. So there may be some infrastructure things that have to as well change to be able to accommodate these new technologies. And as we build out our business case internally, those are the things we're thinking about. Is maybe it makes sense on this part of the rail network, but not on another. So
Okay, great. Next question. Railroads have been operating ever longer trains. Automation will reduce the benefits of this practice. To what extent will automation impact this trend?
yeah, no, interesting question, because you're right. The reason we operate longer trains is because that essentially reduces the number of trains that are out there. So it's one of the things that I think each one of us, like I said, will model to decide how far do you take the automation. So Kansas City Southern, we're a single main line. So where another railroad might have dual main lines for an extended part of their track, they may be able to take advantage of things faster than KCS can, and be able to use the automation. Maybe down one lane of the track, they do certain automation. So it's interesting, and it's a different problem for each railroad, and something that KCS, we have to model to see, does it make sense to continue just to run longer trains, or can we get the same effect with our modeling systems that says, maybe I run 3 shorter trains to be able to meet customer demands. I move as many cars, but because of the automation and the technology, I get the same effect as running, one long train. So we continue to look at that as we make decisions on investments and things like that. But I think it's going to differ for each road.
Okay, thank you. Next question. What are some of the remaining challenges or incidents when operating with PTC, and how often do they affect service? Are they related to interoperability or more specific to a local network or host?
Yeah, I would say it's probably more localized. I'd have to look at my dashboard statistics. We still have, I'll give you a good example where a switch point monitor. So if a switch is supposed to be lined for the main line and our train rolls by it, and that switch happens to bounce, where now the switch point monitor says, I don't know what the condition is. I don't know if it's lined for the siding. I don't know if it's lined for the main line. Well, the problem is the train's already rolled by it. We're past that braking warning curve, so it stops the train. It did exactly what it was supposed to do. So it's those little things that we continue to, kind of iron out as we use the system more and more. And that's why I say it's more localized, because I'm probably seeing more of those, on my main line, and with my operations than I'm seeing them with interoperability. I would say, interoperability, other than, I may receive a locomotive that doesn't have PTC, and I've got to swap that out, has been functioning, pretty well. So, and that's why, this regulation allows us for the next three, at least this year and 3 years to kind of evolve. We're all continuing to learn before, it really goes in full effect and will start affecting, mainline operations. As of today, we have not had, and this is only since January 1st, so it's only 13 days in, we've not had any operational issues where I've had a locomotive that was in the wrong position and we had to move it around. So, but I'm not going to say it won't happen. It might and will, and we'll learn from it.
Okay, and here's another question related to operations. Once a train gets stopped because of an override, how does the train get reactivated to start moving again?
Sure, they have to go through reinitialization process. So there's a process again, and with initialization, they have their own PIN. It goes to the back office to validate that that's a valid employee, that we've got the right track files on there. So they've got to go through the entire process, which is actually relatively quick. It's probably a 10 to 15 second process for them to get back up and running.
Okay, great, good. And we've got two more questions here. I'd love to try to fit these in before we wrap. Does or will PTC functionality extend to network traffic management for purposes of, say, maximizing throughput, avoiding congestion, or increasing speed of network recovery in case of disruption?
Sure. I could have added slides there. It probably won't be PTC. It will probably be energy management, where we would use a meet and pass planner or a mainline track planner. If I use one of those and I have the ability to identify, right, how do I work myself out of a problem? That may say, go ahead and launch these 4 trains that are sitting in Kansas City to Shreveport, launch one out of Shreveport. Right now, my dispatchers are doing that on their own. There is technology that allows us to do that. Now, the next thing is, how do we do the meet and pass all the way down from Kansas City to Shreveport, Louisiana? Well, depending on the size of the train, you can set trains in certain sidings and not trains in other sidings. Well, I'm going to let the technology do that. Again, the thing, since now I control the throttle and the brakes from a fuel efficiency standpoint, if I can send that message to my energy management system, it may say, look, rather than sitting in the siding for 2 hours, you're going to have to wait till the train meet happens anyway. Why don't you slow down to 20 miles an hour, conserve fuel, then you have a 20-minute wait and things move. So absolutely. We didn't even talk about, kind of these operational systems that help optimize the network that will then connect into these other systems that we will be able to, since I control the throttle, control the brakes, I can give it information, or I can give advisement to the engineer that may say, you take control and do this for the most optimal. So yes, we're looking at the whole gamut. PTC will be the underlying system that'll help, provide safety, but we're going to leverage the other systems to be able to take advantage of it. Definitely.
Okay, good. Thanks, Doug. And final question. Have there been any discussions at KCS or between railroads to work with shippers to identify actions that can be taken to leverage PTC to provide mutual benefits between shippers and the railroads?
Yeah, I don't know if it's been specific with PTC. I do know that my sales and marketing group definitely listen to the customers and those ideas that come back with, how do I get visibility on where this shipment is at? How do I get better visibility on ETA? And maybe that's something I'll take back to my group as well, is because, we ingest it and then we take the technology and say, well, here's how we'll be able to do that. And I'm not sure what makes it back to the shippers or the customers to say, here's the path that we're leveraging. So I would say, yes, we absolutely are talking I just don't know what goes back the other way. So I'll ask that question, and if that's, you know, good feedback to, you know, provide kind of, you know, some of the under the cover, how are you doing it? What's the technology? What are you leveraging? I think that would be a fine message, because that really is what we're, you know, doing to be able to identify, you know, where things are at and how things are moving through the network.
Great. Well, thank you. And really thank you for all of this fantastic detail, Doug. We know it's early in the process. It'll be interesting to hear back from you, you know, how it's going in the next year or so. So thanks for the detail. Thanks for taking the time to answer all of these questions. And thanks everybody for attending and for being interactive with us on this final Q&A here. And want to say just again, Doug, thanks to KCS for their support of NIT and this session. And we're looking forward to providing more webinars in this webinar series. And so if folks have ideas for topics or speakers you would like to see, definitely reach out to us and share those with us. You can find my contact details on the website, nitl.org. And also just wanted to give a quick plug. We are offering the NIT League Transportation Summit this year virtually in March. And so you'll be getting an email about that very soon. So hope that you'll check that out and join us for that session as well. So Doug, thank you once again. And thank all of you for joining, and enjoy the rest of your afternoon, and take care.